All right, welcome back everybody to the afternoon plenary sessions. I think everyone got a real good flavor for the conference this morning, the opening plenary and the really interesting breakout sessions. I know I myself attended two really interesting sessions, so I think that's been good so far. I want to thank everybody who presented this morning. It's a lot of hard work to do. It's something that's we all have busy jobs, and so it's great that you're able to take some time out and share the knowledge you have with the wider community. Very much appreciated. So this afternoon we have two more plenaries and then the awards ceremony. Coming up right now is the session on creating buildable packages. I think this is going to be an interesting one where we're really going to learn a little bit about how to really put AWP into practice. So at this point, I guess I'll turn to Alex, Ben, and Cody and Mark, and they can take it away.
Thank you, Alexis. Everybody, good afternoon. I'm Alex Wonderink. I'm one of the presenters here for this afternoon's session titled Creating Buildable Packages. All right. Sorry, just making sure I got control there. All right. So the purpose today, we're going to discuss how to create well-defined buildable installation work packages that enable constraint-free productive construction. We'll start out with a few introductions, and I have the pleasure of providing these introductions as well as a safety topic, kind of dig into why this is important. And then Ben will talk about the principles of creating buildable installation work packages, followed by Cody Austin, who will be talking about 3D modeling and how that software can be leveraged for use in buildable packages. And we'll end it with a summary of our golden nuggets and a Q&A portion. So I'm Alex Wonderink. I'm a member of the AWP team at Eastman Chemical Company. I've been involved in civil and fire protection engineering and contractor safety management prior to this role. I'm relatively new to AWP, so I'm learning a lot. This is my first AWP conference. So learning a lot, but really excited about the potential that this has in our industry. And then next we have Ben, kind of on the opposite spectrum of me. Ben hails from an electrical construction background, but over the past 30 years has built up an impressive resume of experience in the industrial construction industry, serving in E&I management and senior project management roles. Since 2010, he's been a member of the Construction Owners Association of Alberta's AWP Workplace Planning Committee and has co-chaired the AWP Scalable Committee. Ben is a subject matter expert, a real genius when it comes to workplace planning and construction in general, and has co-founded or consulted with several companies over the year, including ConstructX. We also have Cody Austin here. He's a technical sales executive with over 15 years of experience in industrial construction industry, helping customers achieve their business outcomes with Autodesk and partner solutions. And unfortunately, due to illness, Andre Parades couldn't be here today. He is with iConstruct, but he did play a big role in helping put together the presentation that Cody will be delivering later on in the session. All right, let's talk about safety for a little bit, because we don't always talk about how important good planning is for safety. AWP literature tends to focus on the productivity and efficiency gains, but there's a serious safety upside that, at least from my perspective, working as a member of an owner company, we take very seriously and see as very important to the process. In a previous role, I was heavily involved in contractor safety management at one of our larger sites, and going through incident investigations and doing root cause analysis, incomplete planning was often identified as a latent or management system root cause to injuries and near misses. One such case that we had resulted in an employee falling into a trench excavation. While the employee was not injured, the potential for significant injury was significant in this situation. This was a company that was using workplace planning at our site, and the workplace planner had developed an IWP, installation work package, and issued that to the civil crew and civil foremen to do some work in a trench, installing some underground piping. The civil crew completed the work and they turned it over to the rigging crew for removal of the shoring boxes. Sorry, gotta click in here again. There we go. So the installation work package that the civil crew had did not include rigging crew activities. The rigging crew was not fully aware of the full scale of soil stability concerns that we had in the area. And the existing fall protection measures were taken care of by the civil crew as kind of a field constraint and were designed for the civil activities that were taking place. As they were removing the shoring boxes, one of the rigging crew members stepped around to the opposite side of the trench excavation because that gave him a better vantage point for spotting the lift. And there was not any existing safety protection measures on that side, and them being not very aware of the soil stability concerns that they had in the area, he was standing near the edge of the excavation as the shoring box was removed. That edge of the excavation then caved in and the employee fell into the excavation. Thankfully, he was all right. During the investigation, we realized that we weren't adequately planning excavation safety measures, including the fall protection aspects of that. But we also identified a gap in our work-face planning around interactions with crews of other disciplines. And the civil crew, they had a plan and they understood the plan hazards associated with it. They had their IWP and they knew what to do. The rigging crew, they just had a task. They didn't have a plan and they didn't fully understand the area hazards associated with it. So, and this is kind of the key that I want to drive home in my little portion of the presentation here, is that a buildable and constraint-free package addresses all tasks. It includes safety planning, not just for your primary tasks, but also secondary and support tasks. And it addresses handover of work to crews of other disciplines. And it doesn't assume that anything just takes care of itself. So I'm going to pass this over to Ben Swan, and he'll discuss principles of building installation work packages.
Awesome, great job, Alex. Webcam should show up here. Due to respect for time, I'm going to try to stick to the narrative that I've created for these slides, but over the next few minutes that we do have with you, I plan to address each of these items identified here, why they're challenge areas in your work-face planning process, as well as identify possible solutions for you and your organization in pursuit of creating buildable installation work packages. So let's start with the size of IWPs and why it's a challenge. Unlike the definition of work-face planning that has gained unanimous agreement across all silos in the construction industry, the definition of IWPs and what they are has not. In creating the initial work-face planning best practice in the mid-2000s, the Construction Owners Association of Alberta had identified what was meant to be a guideline for the industry, that an IWP would contain the rotation of scope for a single 10-person crew in a single discipline. So whether the shift back then was 5 10s or whether it was 10 and 4, they were looking for the guideline to be packages built between 500 and 1,000 hours. However,
just a quick tech check for you, Ben. Sorry to interrupt.
Yeah.
It seems your webcam view is completely black. So it indicates your webcam is on, but for some reason it's not producing a picture.
Sorry, Steve.
No worries.
Let me just stop sharing and then try resharing. Hey, there we go.
Okay, thank you.
For you, Steve?
It's looking good. Thanks a lot.
All right, thanks. However, what was meant to be a guide for the industry has become a rule, and far too often is dictated down to the contractors by the owners that thou shalt build 1,000-hour work packages. Over the past decade, each discipline has proven that as a rule, it simply doesn't work. Yet even today, both in presentations on job sites, this nightmare of 1,000-hour packages still plagues our industry. So whether we look at the concrete pours or piping tie points, and basically every discipline in between, 1,000-hour work package is simply a very bad idea and creates far more problems than it's worth. I won't spend a lot more time on the problem, hoping that it is recognized in the industry. I'd rather spend some more time on the proposed solution. I think it's important that we understand that the original intent is true, that we want to make sure that our crews have constraint-free work, that they're effectively executing throughout the duration of their entire work shift. We also then must acknowledge that the methodology in attaining the intent, which was based on a project controls theory of certain amount of men working certain amount of hours, is broken and must be discarded for the industry to move forward effectively. Second, I think it's important that we agree as an industry on an IWP definition. And so based on the current knowledge that we understand, let's go over a few points. IWPs are dissected from a single CWP. IWPs are executable discipline-specific work packages of work. IWPs are to be created by planning teams and used by our foremen for our construction workers to execute the work. IWPs will contain all the information needed to execute the work of scope. And as Alex brought up, the safety aspect of that work is very important to have within the IWP. IWPs will also have constraints identified and or mitigated 4 weeks prior to the execution. So based on this current understanding, a proposed definition for the industry around an installation work package would go something like this. An IWP, an installation work package, is a grouping of tasks dissected from a single CWP created by a work phase planner targeted to align with the optimum path of construction. These IWPs will contain all the necessary documents and descriptions required to carry out the scoped work, which is to be for the most effective and efficient installation or completion of the work. The focus in terms of the hours is more to be on the executable IWPs in each foreman's backlog to keep their crews busy for 2 shifts. The third area of a proposed solution in terms of the sizes of the IWPs for the industry is that we need to start tracking the right numbers. And so 3 areas of numbers that are important to start tracking is what are your average man hours per IWP per discipline and per work type. When you get down into the disciplines, if you have the clarity on not just a discipline average, but a work type average, your clarity in estimating ongoing work or future work is a lot more accurate. The second area would be to be able to start tracking how many hours it's taking to build those IWPs. And then on an ongoing basis on your projects, you want to be effectively managing the size of the backlog per foreman, making sure that they have executable work for 2 shifts. There's some cool formulas then that from this information, when you start tracking it, your estimated hours divided by your average IWP average hours will provide you the forecasted number of IWPs on your next project. You then take that forecasted number of IWPs and multiply it by the hours that it's been taking you to build IWPs. You then have a very accurate estimating effort it's going to require to build those IWPs. An interesting note on actual average sizes of IWPs over a 3-year average on major projects. Piping falls between the 700 and 800 hour range. E&I falls between the 400 and 500. A 2-year average running basis, the average IWPs for piping fall down into the 400 to 500, and E&I fall down into the 200 or 300. Oh, hopefully I didn't click it twice. So this next area, let's turn our focus onto a class 1 material takeoff versus a class 1 estimate. Due to the factual knowledge of this item today, I'll specifically target the electrical instrumentation disciplines. There's a distinct difference between an output of a class 1 estimate and a class 1 material takeoff. Contractors will not expend the effort for a class 1 material takeoff when bidding their work. Owners are consistently inconsistent with their project work breakdown structures, and contractors are left having to combine groups of work into a work breakdown structure in a proposed best manner to get the job, not so much in how to execute the job effectively. Owners then do not allow enough time for the contractors to effectively close this gap between their original estimate and the required Class 1 material takeoffs. Credit needs to go for this slide to AWPU. It's a great slide that I grabbed from them in identifying through the life cycle of a project through POC 1 to 4 and down into the IWP, that we're going from a granularity of a Class 5 estimate down into a Class 1 estimate. Same logic happens with the schedule, but this is a great visual in terms of the classification in relationship to it. However, this engineering bill of material in this example is a heat trace bill of material often provided by engineering, and we can definitely produce a Class 1 estimate from that. From this bill of material, we can complete an accurate estimate in relationship to both labor hours and material costs for installation of this heat trace scope. We can order the correct material in quantities without a lot of overages or underages. However, we cannot tell what process or line size this material belongs. We can't tell if this material is on module or off module. We can't tell which of this material is for the interconnector between modules. We cannot coordinate the EHT IWPs with liner equipment releases from the mechanical trade. So although we can have an absolute accurate estimate in cost and hours to create buildable work packages, this bill of material information provides us no value of planning our work in creating buildable work packages. So what happens on a project when the deltas between the estimate and the MTO are not addressed? Is it really an issue, and do we need to address it? The short answer, of course, is yes. It happens on a regular basis, and the degree of discrepancy in conjunction with the project's management team determine how off the rails the project will go. A few years back, I had the privilege of working with an electrical contractor to implement work-phase planning on a major project. The contract had been awarded based on their estimate and the project schedule based on the work breakdown structure from that estimate. We proceeded with a Class 1 material takeoff to support the building of IWPs and discovered many discrepancies between the estimate and the MTO. Far too many discrepancies to mention here. However, to make a point, one of them was the estimators had put all of the field run tray into CWA2. So where do you think the crews charged their time in CWA4 when they were installing field run tray? When I asked the superintendent, he said, well, lighting, of course, it's got lots of hours. For this example today, we've simply picked out of the 3 CWAs to show the level of discrepancy found between the estimate and the MTO, and yet the totals didn't change. And so the work breakdown structure, as you can see, the delta between the estimate and the MTO in quantity was over 300% in CWA1 on tray install. When we fell down into CWA2 and the cable install, discrepancy was over 700%. In CWA4 on cable install, it was 343% in delta in quantity. In all of these cases, there was no discrepancy. What it was the Class 1 material takeoff gets down to a tag level, and I'll jump on to the next slide. But this is definitely a challenge specifically around the E&I and understanding that there is a definite difference between an estimate and an MTO. And that there needs to be allotted time for that transition upon or after award of contract for a contractor. So by no means, this is not an exhaustive list of the details of the outputs of an estimate or an MTO, but rather a focused data set specifically identified for its requirements in creating buildable work packages. Total quantities and hours for a CWP by cost code is a given and provided by both the estimate and the MTO. This information is required for both project controls and construction management and is used for both planning and tracking a project. The engineering tag in this listing can be applied to different disciplines, but refers specifically to the electrical instrumentation disciplines. This level of detail is mandatory data for creating buildable work packages and is the output only of a Class 1 material takeoff. This information is required by project controls, by construction management and the QC departments of your projects. And it's used for planning, delegating, tracking, and verification. Two key aspects to solve this challenge are time needs to be allotted for contractors to what's often referred to as a true-up between the contract award and start of execution. And there needs to be an understanding of agreement that all identified discrepancies within a work breakdown structure in quantities and hours between the estimate and the MTO to be addressed and correctly reflected in the project schedule and reporting. So the next item is around constraint management. It can be identified as any condition. A constraint can be identified by any condition that prevents your work plans assigned to construction crews from being successfully executed in the field. Construction, industrial construction specifically, is a very dynamic environment with constant evolving doors of change, along with the sheer volume of work on major projects makes the constraint management process of identifying, tracking, and resolving makes it a very reactive process. Our industry status at best when it comes on how we manage constraints is informal, ad hoc, and heavily dependent on the supervisors and planners' experience and judgment. Proposed solution would be, in the first step, would be to define what your process is and have a written procedure. Written procedure should be able to identify how are you going to classify your constraints. Who is responsible? When are they going to do it, and how are they identifying, assigning responsibility, and ultimately resolving your constraints? The third key item is who's responsible and what tool are you providing them to track and report the constraint status to identify constraint-free IWPs for execution. The second step is simply to get started. If you haven't already, get started. Third is to check out vendors like O3 Solutions and WorkPack software, which have construction-based constraint management that can greatly enhance your project's team's abilities around constraint management. The next item that we want to look at is around IWP content and IWP templates. There is sometimes a communication or a thought that, you know, if you can get a template, then all your problems go away. I don't think that that's a true case. I think the content is very important. I think a table of contents is critical, and the template just represents that. One of the key things we want to be able to identify in the challenge of IWPs is that we don't want to build encyclopedias, we want to build more comic style IWPs. And then 4 areas around the challenges is to understand the skill set of the foreman and the work being planned. Years worked do not always equal experience in the scope of work being planned. Foreman's understanding of the contractor's quality work practices. Foreman's understanding of the contractor's safety work practices. And then, of course, the foreman's understanding of the client standards and specifications should all be taken into consideration when addressing the content of the IWPs. The content of the IWPs on a little diagram on the right is basically, you know, you've got a bunch of components and engineering tags and possible tasks that make up the scope of the IWP. And you've got a bunch of data around it in terms of material lists and drawings and schedule IDs, reference drawings, pictures, work practices, work scope, safety access. There's a lot of content. I'm a believer that based on the knowledge and understanding of where your foremen are at in their skill sets and knowledge, greatly determine the content that goes into those IWPs. So proposed solution is a table of contents. You do not have a defined table of contents in your work-based planning procedure. This is a great starting point. Again, the key thing is to get started and iterate and to continually improve it. Understand that not every item on your table of content needs to be included in every IWP. that you can adjust your IWP content to better align with your foreman's crew and knowledge. Remember that consistency equals success. I relate to do an analogy to golf, right? For all those golfers out there who love the game but are not consistent, you usually lose a lot of balls. But when you start golfing consistently and you start getting that consistent swing, you get a lot more successful, you keep a lot more balls. The same goes for building out IWP content and templates for your crews. Get consistent with the content that's going into them. The template style, I wouldn't get stuck on. I'm an advocate for PowerPoint because it's easy to use and it's easy to learn. Other templates use Excel, PDF, and just my personal preference, my last choice would be in the area of Word. And with that, we'll pass it over to Cody.
Hey, thanks, Ben. Hopefully you can see me. Good afternoon, everybody.
Guitars look good in the back.
Oh, thank you. Yeah, too bad it's not a concert. Otherwise, I'd play for everybody. But I'm going to be, teaching you today about 3D models and how 3D models can be applied to the concept of creating buildable packages. I'm going to help you understand some of the current challenges with today's 3D models, and then understand what's needed to improve 3D model content and reliability. And then understand the opportunities and value 3D models enable project teams and the advanced work packaging process. Let's see, make this, there we go. So these are some of the industry challenges with 3D models. First, in our contracts, there really isn't much specificity, around the 3D model. There may be some, mention of what format it should be delivered in, but beyond that, there's little information around how the 3D model is going to be used, how, downstream, in construction and operations, for example. But in today's contract, there really isn't much language around the 3D model. 3D models are pretty consistent in terms of they are being handed over to owners and handed over to other parties like construction. But the manner in which they're delivered in, their formats, the data or information within these 3D models is very inconsistent. Especially from project to project, small cap to large cap, from client to client, company to company, just very inconsistent in the 3D model data that downstream people are receiving. And what's kind of driving this inconsistency is a lack of adopted model development and data standards. And I'll talk in the next couple of slides around how standards can help us drive a better handover of more consistent 3D data that can be highly valuable in downstream workflows. And there really is a limited understanding of what you can do with the 3D models. Some people aren't aware you can do anything, and there are some people, more technical people that can really, unlock the power, unlock the data in the 3D models to really drive different insights and help improve, decision making. But there really still is a limited understanding of what can you do with 3D data and what are the requirements to be able to do those types of things. And as we all know, the 3D model lives in engineering. It was, it's born in engineering, right? We've been creating BIM and 3D models for 40 years, right? And think North Sea offshore, right, where Aviva and PDMS got its start. So for over 40 years, we've been creating 3D models, but all those resources around BIM and the 3D data still live within engineering. And so there are some people in construction and operations that are familiar with 3D data, but there's still a knowledge gap outside of engineering. And then finally, there's limited investment in using 3D models to drive automation and decision making. We'll talk about different use cases with the 3D model, but obviously there is investment in terms of upskilling people, in terms of making sure you have the right technology, in terms that you have the right processes in place and people adhering to those processes and standards, so a time investment as well. And so there is investment needed, and but there's lots of return on that investment. I'd like to talk to you a little bit about what other industries outside of the industrial space are doing to help drive better use of 3D data outside of architectural and design or engineering. There's a group called the BIM Forum, and they have published a level of development specification. It's publicly available at the link below. But this specification enables practitioners, really in any industry, to specify and articulate with a high level of clarity the content and reliability of building information models, or 3D models, at various stages in the design and construction process. This clear articulation allows model authors to define what their models can be relied on for, and allows downstream users to clearly understand the usability and the limitations of the model that they are receiving. And so you may have, if you're familiar with BIM, you may have heard of a BIM use, and a BIM use drives the level of development and the data requirements of these 3D models. So, BIM was born in engineering and design, and common BIM uses are clash detection, automated drawing production, getting MTOs for estimates, for example. These are very common BIM uses in engineering and design. And so that's kind of why you see the models being handed over from engineering and design, be developed to the level that they are, right? They're really centered around those engineering and design workflows, but there's BIM uses downstream in the supply chain, in construction, in operations. You may have heard of digital twin, right? There are use cases that we can exercise through the 3D model. And so that's why it's really important, just like with advanced work packaging, you get construction's input at the very beginning of the project, defining the sequence of construction. You need all stakeholder input on these BIM uses. How do these downstream people, or really any stakeholder, plan on using the 3D model? And those BIM uses then drive to what level of development and the data within these 3D models is to be required in order to facilitate those downstream BIM uses. So here is a chart. It's along the top, you see an illustration of the different levels of development, 100 through 500. And in this use case, it's around structural steel. And you'll see in which phase of projects are models developed to this level of development. So with 100 and 200, you're still in the pre-feed feed stages. And then as you get into detailed design, you move to the LOD 300 and 350. And then as you move into fabrication and working with your supply chain, you're moving into an LOD 400. And then LOD 500 is simply field verified. And so this really defines your as-built model that can be used to support digital twin initiatives by owners. And then you see below the swim lanes here for the different disciplines that are typically included in 3D models today in the industrial construction space. And then you see typically to what level of development these discipline models are developed to. And if you're familiar with work-based planning and using 3D models, you'll see that, or know that the structural disciplines and the piping disciplines are typically brought to an LOD 400 by those suppliers, by your structural detailers and fabricators, and by your pipe fabricators. The other disciplines, it really depends. And again, this is kind of an average of what the level of development is for each of these disciplines. But if you want to start, work packaging and building executable packages using the 3D model for the electrical disciplines or the instrumentation disciplines, you need to consider, what level of development your models are going to be developed to, and then what data requirements are needed. I know there's been some challenges with the civil models, for example, when you have, large pads that you may pour. Overnight, over 48 hours continuously, but you may need to break up, the 3D model to represent those pores, and that can be a challenge. And so again, those BIM uses need to be defined early on by all parties so that the model that is being handed over downstream can be used to facilitate those BIM uses. So another thing to remember is 3D models are databases, and what makes them a little so 3D models are databases, and typically what's handed over from engineering to downstream participants is a single file, a single model, a federated model, a database, if you will, and that can pose some challenges. What I recommend and what I've seen on successful projects is that what's delivered from engineering to downstream stakeholders is one model for every construction work package. And so this really helps. It provides more flexibility to those downstream and working with your model data. So it's already easily aligned to the path of construction and to your level 3 activities, and it's more manageable. I've seen some very large 3D models from engineering that contain the complete site, not just the unit that's being built or your brownfield tie-ins. It's the complete site, and people receiving that downstream can be quite overwhelmed. And so there's really both sides of the spectrum. We're receiving data we're receiving 3D models with little data, and we're receiving 3D models with a lot of data. And so you can have problems on both sides. And John Banda in our breakout, the Autodesk breakout, talked a little bit about the use of Navisworks and iConstruct and how those tools are being used to help condition models to make them more effective for downstream purposes. But the best practice here is for engineering to deliver one model per CWP, and to deliver it in native format where possible. Typically it's a Navisworks format, which is fine, but deliver the DWGs, the DGNs, for the Aviva would be RVMs and attribute files. For Smart 3D it would be view files and MDB2 files, and then for structural detailing it would be something like IFC files, which is industry foundation classes. So it's a common structural detailing format. But deliver the native format where you can, so that downstream users can federate their own model. Again, it provides more flexibility with how these models are used downstream. But again, they're a database, and what makes 3D models different is that they contain geometric data, and this is where that level of development specification applies. Is to what level of development am I modeling pipe lines or pipe spools or pipe components, cable tray, instrumentation. I've seen pressure transmitters being represented similar to this, like a box. Others I've seen instrumentation modeled to a very high level of detail, where they may have collaborated with their suppliers to receive models and make some very nice looking 3D models. But like other databases, 3D models also contain data, and so this is where data requirements, like the AWP data requirements, can come into play. And at a minimum, you need if you intend on using this 3D model to do different things with, you really need a way to connect this 3D model to other data sources. And that's typically a tag. And so here I've taken a screenshot from the AWP data requirement showing that, from a piping component perspective in a 3D model, that tag is your primary key. And so that really helps you and enables you to associate your 3D model with the rest of the project data that may be managed elsewhere. There's a lot of thoughts and arguments around, the data should live in the 3D model, but that's really unrealistic. And so we need a way to easily connect the 3D model to things like the AWP master index, or to document control, materials databases, project controls databases, etc. You see the list there. By being able to do that, we're able to do one thing here is reporting. And so in terms of developing executable packages, using a 3D model, if we have it integrated and associated with our the ecosystem of project data, reporting and package building can be fairly automated, and you can build these reports here on the right hand side very quickly. And so again, the 3D model is a database, and creating an executable package. When I think of what's an executable package, well, it's a package that's constraint free, right? I have my material, I have the resources, equipment, drawings, the workface is accessible. So it's really a constraint-free package, and our constraints are being managed in all those databases you saw in the previous screen. Material availability, IFC drawing status, our schedule, turnover information, commissioning information. And then, when you get into operations and maintenance, you may have, smart devices or Internet of Things, or, thickness measurement locations. You may be managing those in a database. So all that constraint information is typically managed in a database, and you're typically looking at that information through a spreadsheet, some sort of tabular spreadsheet, maybe looking at it through some charts and graphs. But by connecting that data to the 3D model, we can start communicating that same information and understand that data in a spatial context. And so we're able to visualize those constraints. And so that's why workface planners are using the 3D model to understand, in this case, what the material availability is. What is the fabrication status of these pipe spools? What is the issue for construction status of the drawings associated with these pipe spools? What's the activity associated with them? We're able to now visualize that information in a spatial context, and that helps us understand trends and impacts and relationships, and ultimately risk, understanding risk, and helping us to improve decision making. For example, work package feasibility. And some of our customers at Autodesk are doing some really interesting things with our technology. This is a really great example from Saipem, who are using and integrating the 3D model with that ecosystem of project data within the context of Power BI. So here's a Power BI application that they've developed, or a screenshot of it, to help understand information in the context of the 3D model to drive feasibility analysis, or to simulate in a 4D sequence, animate the path of construction. Again, to really help understand and communicate data that may be typically consumed, through a spreadsheet or some pie chart, as an example. So kind of wrapping up, I'll close with, kind of what's next. A lot of discussion around artificial intelligence. It's a big buzzword, and people are still trying to figure out what it means. But ultimately, we need to understand how can we leverage it, and what do we need to do in order to leverage it, and how can it be applied to work packaging. So we all know data is a precious commodity. There was an Economist cover, data is the new oil, and the world's most valuable resource. And so data is what drives artificial intelligence. If you don't have good data, you're not artificially intelligent at all. You really need great data, and a lot of data, to drive AI. And what is AI? I was on some internet forums, and somebody mentioned this, to kind of put it simply, that artificial intelligence is applied statistics. And so the definition of applied statistics, it includes the planning for the collection of data, managing data, analyzing, interpreting, and drawing conclusions from data, and then more importantly, identifying problems, solutions, and opportunities using this analysis. And if we were live in Houston, I would ask in the audience, how many of you are hiring, people with applied statistics degrees or data scientists to your companies and are working on your projects? Because again, data is going to unlock tremendous value downstream for EPCs and owners. And companies need a data strategy in order to capitalize on artificial intelligence and these following opportunities. The first one is around predictive risk and leading indicators. We have lots of data. We don't have a volume of data problem. We have a leveraging data problem, and we're typically looking at lagging indicators. A lot of the reports and spreadsheets and charts are all built on lagging indicators. By normalizing and standardizing the way that we collect data and execute projects, it's going to allow us to start developing leading indicators and start being able to predict risk on projects, and in real time too. So you see a couple of examples here along the bottom. One of my favorites is leveraging the words that you enter into an RFI, be able to give that RFI a risk score based upon previous RFIs that contain some of those same words. And so the computers and technology these days can really take advantage of data and illustrate and help identify where you may have trouble down the road, and help us move towards more leading indicators. The second and last concept is around generative design. You may be familiar with it. If not, it's an iterative design process that involves a program that will generate a certain number of outputs that meet certain constraints. And a designer will be able to fine-tune the feasible region by selecting specific output or changing values, changing input values, ranges, and distribution. And what makes it generative is that it learns over time. It refines itself with each iteration as design goals become more and better defined. So instead of generative design, how about generative work packaging? Because today you have work-based planners sitting in the construction trailer in front of a laptop, using the 3D model and manually selecting things in the 3D model and adding those to a work package and trying to understand what are the constraints associated with those work packages, and so it's a very manual process, and it's not an optimized process. And so if we can work to develop rules and algorithms around what makes a good work package and based upon previous projects and previous data, leverage those KPIs and those insights in that rule or algorithm, we can really leverage the computer to optimize and automatically work package our 3D models for us that meet certain criteria. And so here's an example. Autodesk used this concept of generative design to optimize the layout of our office building in Toronto. And so we're trying to optimize the floor plan of our office around things like distractions and congestions, access to daylight and visibility of windows, work style. We're looking at all these different KPIs that would factor into what makes a good floor plan a great floor plan. And the algorithms are able to iterate and optimize and score each one of these designs, and then a human or even a computer can then select a narrow subset of the output and generate even more options based upon those optimized KPIs. And so you may be familiar with the spider or radar graph. You saw it on the previous slide there, but this may be what a radar graph looks like for some work packages that have been created using artificial intelligence. And so we're able to see how these different work package combinations and options change as we turn the dial over here and over here and over here on these different KPIs. Through generative work packaging, we can really optimize what makes a good work package and makes it executable, makes it safe, makes it high quality, delay free, etc. So I think that is my my last slide. I think I may have some golden nuggets. Was Alex going to cover this, or I can?
Yes, sir.
Go ahead, Alex.
And thank you, Cody. I'm pretty blown away by all the potential that there is in the 3D modeling space. But we'll go ahead and wrap this up with a few golden nuggets here, and then we'll move into the question and answer session. So the first one I have here is that buildable packages address all tasks, and we saw this in the little safety moment at the beginning of how important it is to make sure that we're addressing all of the tasks associated with not just the primary task, but also secondary and support tasks. Buildable packages are based on scoped work and not a certain amount of hours. We shouldn't be holding our contractors to a set number of hours, say like 1,000 or whatever, but instead breaking it up in a way that makes sense from a constructability standpoint. Also, there's a difference between class 1 estimate and a class 1 material takeoff that matters when creating buildable packages, especially in the electrical industry. From Cody, we saw that BIM use cases need to be defined early in the project definition, and model development specifications and data requirements should be adopted to satisfy their implementation. And the key here is early. You got to get those stakeholders in early. It's a lot easier to build in the attributes that you need for whatever use cases you're going to use that model for early on at the beginning than to try to fit those in towards the end of the project. Also, engineering and design contractors need to be provided with native design data or exports along with federated 3D model to improve downstream use of the 3D model data. That's your native files such as your DWGs, your DGNs, VUEs, and also to make it easier for the downstream users, especially construction, having that split up into separate model files for, say, one 3D model for each CWP is really helpful to not get that overload of data. Also, strategies on the standardization of data is required to take advantage of automation, predictive risk, and artificial intelligence. Really just standardizing data across the board. Anytime you can do that, it makes it better. We're going to move on to the Q&A time now. Lloyd, I believe you're going to be facilitating, correct?
Correct. I
All
will
right,
be
cool.
facilitating. And Ben and Cody, yeah, you want to join us? Steve, could you throw up the Slido slide, please? And what I'd ask is, please put your questions in through Slido. And then as the questions start to appear, please vote on the ones that you're most interested in hearing, because typically we get more questions than we have time to answer them. So if people could go in and ask their first question. And one of the things that I'd like you to consider, Ben's is it 4th or 5th generation electrician, master electrician? Oh, just second?
Second
Oh,
generation,
you lied to me.
3rd generation tradesman.
Well, and your son's a tradesman, and your grandpa's a tradesman, and your dad's a tradesman, and you're a tradesman. So I think when it comes to understanding construction, we got a ton of experience, even generationally in Ben. But one of the things that I want you to think about when you're asking your questions, there's this belief that, well, we kind of done a pretty good job now on pipe, and we've done a pretty good job on steel, so we've kind of got this packaging licked. And then there's electrical, and then there's mechanical, and then there's a whole bunch of other disciplines. And so maybe asking Ben some questions about different disciplines and how they should be packaging their work. Steve, can you flip us over to the question portion?
For sure, yeah, just waiting for the first of the questions to roll in here.
Okay, so I'm going to ask you one, Ben, and it's related to package size. So we're now seeing AWP applied to scalable projects, and in some projects, the amount of work and the crew sizes are very small as compared to what we came up with when we did the first version of advanced work packaging. How big and small have you seen packages in your experience, and appropriately sized packages?
So if I talk specifically on the E&I side, I've seen packages as small as 20 hours for terminating a panel. And I've seen cable pull packages in the 4,000 and 5,000 man hours, and everything kind of in between. Again, it's the industry has got to get away from hours per package and focus on, if you're building a package for terminating a panel, you want to be able to package the work to do that scope, understanding that the intrinsic relationships tied to the termination of that panel now release that work for QC to do their work. If you tie that in with a bunch of other panels just to get hours, you really are shooting yourself in the foot when it comes to productivity and increasing effectiveness in the field. Vice versa, if you're pulling all of the cables off of an MCC, all of them, right? So.
Great. So quite a range there, and my guess is they may average to that 1,000 to 2,000 hours, but
Well,
that's kind of like the average size of shoe. It's still got to fit the person you're building it for.
Yeah, if you look at a 2-year average in the portfolio world on E&I, the packages fall in that 200 to 300 range, piping 400 to 500, as opposed to when you get into the major projects in E&I, it was really falling in the 400 to 500 range, and piping is falling into the 700 to 800 range. And those numbers, again, we should be tracking those numbers for future estimating of planning level of effort to build IWPs, not for determining the size of the IWPs.
Great. So we've got a number of questions. Please vote on the questions to make sure that the ones you're most interested get addressed first. But let's go with the first one. How do you handle the challenge of packaging instrumentation and electrical that often packs through multiple work areas?
So when it comes to packaging instrumentation electrical that would go across multiple work areas, the only thing that falls into is the task of cable. In that case, you're typically dealing with, or you will be dealing with, your primary power cables and your primary trunk cables for your DCSSS and BPS systems. I would set up those packages from the source destination. And I would coordinate to ensure that the packages around the cable tray are complete and signed off. If you're in Canada and you haven't signed off the cable tray and you're pulling cable, you're breaking the code of the Canadian Electrical Code. So if you're going through multiple areas, you're definitely dealing with trunk cables, and they should be set up from pulling from the source destination, from the source to the destination.
Okay.
Great question.
Next question we've got is, how do we get vendors like GE to give us better data-rich 3D models that support AWP?
Yeah, it's a great question. I'll take that one. Yeah, so the supplier and the supply chains, folks like GE, Siemens, Victaulic, Hilti, et cetera, have 3D data, and they often use this data to actually manufacture these products. And so they're typically developed to a very high level of detail to support the manufacturing process, but they also contain a high level of perhaps intellectual property in some of these models. And so I highly recommend collaborating with their suppliers. I'm reading more into this question. There's lots of ways that 3D data from your suppliers can support AWP. AWP goes from engineering through construction. One common thing that really causes a lot of problems is not getting proper nozzle locations or connection points. That can cause huge headaches when you install things in the field, or it can cause lots of revisions that take place if you receive that information late. You also need to consider what data needs to be in the 3D model. Here it says a data-rich 3D model. So I would, again, maybe go back to the BIM uses. How are you going to be using this 3D model? And that drives how the 3D model is developed in terms of level of development and how it's broken up, but also what data needs to be in the model. I would argue that not everything, not every bit of data needs to be in the model. We need to be able to easily associate or connect the 3D model with other data sources where it may make sense to manage that data, packing information, or procurement information associated with the vendor model.
Okay, great. Thank you. We've got another question here. A lot of the data needs to originate with engineering. However, engineering functions often resist building data into the models or other tools to streamline downstream activities in procurement and fabrication. So how do we get engineering to come along and integrate the data? And I think this may involve our owners, because ultimately somebody's got to pay for this, but I'm curious to hear what you guys think.
I'll mention something real quick. You're right, Lloyd, on the owner participation in that. The owners really can help dictate to the engineering contractors or to the owner's engineers what data needs to be built into that model and what attributes need to be put in for each of the different elements in the model. And so to really help that out, I would recommend, and what Cody, I think, mentioned in his presentation, is having standards. And if you present those standards at the beginning, even during the contract and bidding phase, to say, hey, we need the model to be able to do this because we want to be able to do this downstream. That's the best solution. Now, if you're a contractor and you're trying to work your way up to get engineering to give you something that would support your processes, I don't know, maybe Cody or Ben has some advice on that front.
I'll stay quiet on this question.
Cody, anything to add?
Sorry, I'm on mute.
I think you're muted.
Yeah, so I did have stuff to add. Yeah, so again, I think there's a lot of misunderstanding around what data needs to be in the 3D model. Again, a lot of people think all the data has to be in the 3D model. There's a question about modeling being the single source of truth. No, we don't need, all of the data that's found on a mechanical data sheet, in the 3D model. We need a way to be able to connect that piece of machinery or pump to that data sheet where that information can be found and is managed. Because with this approach of pushing everything to the 3D model, you're duplicating data, right? And so then you have problems with the confidence of the data, the inconsistency of the data, and managing the data in multiple places. We need to manage the data where it should be managed by best-in-class tools. Sometimes that's Excel, but we need to be able to federate this data and connect this data together.
That's great. It's now half past the hour, and I'm not sure if Alexis is going to come back and lead us into our breakout session, or if he just wants me to do that. But
you're already up.
As you can see, okay. I was going to say, as you can see, there are a number of questions we didn't get to. Now, there's two ways to address those. One is just send the questions directly to our speakers, and they'll get them and they'll respond to them. The other way we can address them is tomorrow we have a half hour at the end of the day to try and catch anything that you may want to ask. So we'll keep these questions and then go through them and pick a sample of them to address at the end of day 2. So at this point, you're on break for a half an hour. We're coming back to hear what I think are always the highlights of these events, and that is an actual case study based on a real project. LyondellBasell and their contractor and one of their consultants are going to be speaking. Definitely don't want to miss that one. And then after that, you'll be able to find out who won the first 2 leadership awards, the one for North America and the global one. So again, you don't want to miss that one either. So we'll see everybody back here in half an hour. Thanks very much. Come to the big room.